Let's look at other indeterminate forms. So let's say we have two functions, f of x is equal to 0. Okay, so let's look at 0 times infinity. So let f of x is equal to 0 and g of x is equal to infinity, and we want to figure out the limit as x approaches a of f of x times g of x. Now in this case what we do is we take the limit as x approaches a of, now g of x is infinity, right? So we take it down, but we can't just take it down, so we have to take the reciprocal down. So 1 by g of x. So here what happens, 1 by g of x, if we want we can take g of x top. So normally that is what we do. Here we are doing the reverse of that. So instead of multiplying, we are dividing by the reciprocal. And now if you notice, f of x is 0 and 1 by infinity would be 0. Or limit as x approaches a of f of x comma g of x is equal to limit as x approaches a of, now if we do the other way around, right, instead of taking g of x down we take f of x down. So then what happens is 1 by f of x. Now remember this is 0 by 0 form. This becomes infinity by infinity form. And in either case we know how to do it. Okay, so let's look at the next form, that is infinity minus infinity. So let limit as x approaches a of f of x is equal to infinity and limit as x approaches a of g of x is equal to infinity. Then remember we are looking at subtraction. So limit as x approaches a of f of x minus g of x. Limit as x approaches a. Now instead of taking f of x directly, we can say f of x times 1. Now what we do is we take f of x down. So we say 1 by f of x minus 1 by g of x. And now we do the subtraction. So 1 by f of x times 1 by g of x and 1 by g of x minus 1 by f of x. Now in the numerator if you notice 1 by g of x would be what? This is 1 by infinity. 1 by infinity is 0. Here again 1 by infinity is 0. So this becomes 0. Denominator again 0 times 0. So this becomes 0 by 0 form. Again we know how to solve this. Okay. Now the rest of this one, 0 to the power of 0, 1 to the power of infinity and infinity to the power of 0. So let limit as x approaches a of f of x to the power of g of x. When limit as x approaches a of f of x equal to 0 and limit as x approaches a of g of x is equal to 0. This is the first case, 0 to the power of 0. This is the first case. Second case would be, let's say this is 1. The second case is limit as x approaches a of f of x is equal to 1 to the power of infinity. So 1 and limit as x approaches a of g of x is equal to infinity. Third case is limit as x approaches a of f of x is equal to infinity, and limit as x approaches a of g of x is equal to 0. Third case, that is infinity to the power of 0. This is 0 to the power of 0, 1 to the power of infinity, and infinity to the power of 0. Now, in each case, remember this is to the power of, so exponents, we know how to bring down the exponents, right? So let y is equal to limit as x approaches a of f of x to the power of g of x. Now take the log of both the sides. So log y is equal to limit as x approaches a of g of x log f of x. This would be what form? G of x has come down. So g of x is 0 here, g of x is infinity here, g of x is 0 here. So it will be either 0 or infinity. Now this, change it to 0 by 0 or infinity by infinity form and start applying L'Hopital's rule. Evaluate the limit using L'Hopital's rule that we know already. Now remember, now we have log y is equal to L. This L has come by using the L'Hopital's rule. This is log of y. Now how do I get rid of this log? Exponentiate it. So e to the power of make it. And this also do the same. Then what happens? E and log gets cancelled out and we are left with y is equal to e to the power of L. So that would be the limit. Now, let's actually solve some problems to understand how the whole thing works. Limit as x approaches 0 of x log x. Now here, if we take the limit directly, it becomes 0. Log of x is actually minus infinity. So I'll just say infinity. So it is in 0 times infinity. That's the form. Now we have to convert it somehow. So let's say limit as x approaches 0. Now let's take x down. Log of x by, now if I'm going to take multiplication, convert it to division, I have to take the reciprocal. Yes. Now let's do the L'Hopital's rule. So limit as x approaches 0 of derivative of log x, that is 1 by x, derivative of 1 by x, which is minus 1 by x square. Now let's say x approaches 0 and let's again bring it back to multiplication. So this becomes minus x square. So here x and one of the x's get cancelled and the limit becomes as x approaches 0 of minus x, and this is equal to 0. Okay, limit as x approaches infinity of x tan 1 by x. Here tan 1 by x is 0, and if x goes to infinity, here as x goes to infinity, it becomes infinity times tan 1 by infinity is infinity times 0. Straightforward. We can convert this to x times infinity. 1 by x goes to infinity, so that we take down 1 by x, and we straight off know it is an identity, so this becomes 1. Now, if you don't remember that this is 1, then you might have to take a few additional steps. That's all. So limit as x approaches infinity of this, split it, 1 by sine 1 by x times 1 by cos 1 by x divided by 1 by x. Now this you should know is 1, and when we take the limit of cos 1 by x, that is also cos 1 by infinity, that is 0, cos 0 is 1. Okay, let's do a little bit complicated one. Limit as x approaches 0 of log of 1 plus x sine x divided by cos x minus 1. This is a straight of, let's see, which form is this? 0, sine 0 is 0. 1 plus 0 is 1. So log of 1 is 0. Cos x is 1. 1 minus 1 is 0. So this is of 0 by 0 form. Okay, so we can just start applying L'Hopital's rule. So let's say f of x is equal to log of 1 plus x sine x, and g of x is equal to cos x minus 1. F prime of x would be 1 by 1 plus x sine x times, and here we have to 1 plus x sine x. 1, if we differentiate, it becomes 0. This becomes sine x plus, I am applying the product rule, and this becomes x cos x. Here g prime of x becomes minus sine x minus 1 minus 0. So this minus 1 disappears. Okay. Now here it becomes in the denominator, in this case it is sine 0, and this becomes 0, and here 1 plus 0, so 0 by 1, and here it is 0. Should we take the next this one? Especially with this type of things, now sometimes when we actually do it, it might become when we actually do the division in this particular case, it may get simplified, it may change form because of simplifications. So let's actually put it in that form. So limit as x approaches 0 of f of x, now f prime of x by g prime of x is equal to sine x plus x cos x by 1 plus x sine x times minus sine x, right? This would be 0 by 0. Yes, so this is 0 by 0 form. Okay, see, because of this multiplication, the denominator is becoming 0. Okay, so which means we need to go one step further and apply L'Hopital's rule once more. So f double prime of x would be sin x is going to be, this would be sin x is cos x differentiation, plus this would be cos x plus x as it is minus sin x. Okay, let's simplify this and see where it takes us. Plus cos x minus x sin x, which is 2 cos x minus x sin x. Okay, now let's take g double prime of x. So here let's first simplify this. Differentiate with respect to x of minus sin x minus x sin square x. So when we differentiate it, sin x becomes cos x minus, here we have to apply the product rule, So sine square x plus x as it is 2 sine x cos x, okay, minus cos x minus sine square x minus 2x sin x to cos x, or what we can do is we can say 2 times sin 2x. And now let's take the limit as x approaches 0 of f double prime of x by g double prime of x. So 2 cos x minus x sin x by minus cos x minus sin square x minus 2 sin 2x. Now if we take the limit, what happens? Numerator, this becomes 2 minus 0, and this becomes 1 minus 1 minus 0 minus 0, 2 by 1 and minus, okay. So let's take minus common out and take it up. Now let's take the limit. Minus 2 times 1 is 2 minus 0 by 1 plus 0 plus 0, which is minus 2. So that's the limit. Let's do the next one. Limit as x approaches 0 of cosec x minus cot x. What form is this? And this is infinity minus infinity. Remember, limit as x approaches 0 of, first let's convert them into this form. Cosec x is 1 by sine, cot is cos x by sin x. Let's sin x 1 minus cos x, okay. Now if we take the limit, what happens? Cos x is 1, 1 minus 1 is 0, sin x is 0. So this is 0 by 0 form. So which means we apply the L'Hopital's rule. So 0 minus cos x is minus sin x. So minus into minus plus sin x by sin x is cos x. Now if we take the limit, this becomes 0 by 1, which is equal to 0. Okay. Fifth, limit as x approaches 0 of 1 by x square minus 1 by x tan x. This is what form? This is 1 by 0 and this is 1 by 0. So infinity minus infinity. Let's see what happens when we do the subtraction. So common denominator would be x square tan x. This would be tan x minus, and here tan x is there, x. So denominator is 0, tan 0 is 0 minus 0. So this is in now 0 by 0 form. Now how do we go forward? Remember tan x by x. X by tan x is 1. So let's split them up. So tan x by tan x minus x by let's say x square times 1 by tan x. Now what do I do? I need an x here. So let's put an x here. Now if I'm going to put an x here, I have to put an x in the denominator as well. So I put it here, and now I split the limit itself. Tan x minus x by x cube times limit as x approaches 0 of x by tan x. If you remember that limit x goes to 0 of x by tan x goes to 1. fine. Otherwise, again you apply L'Hopital's rule and solve it. You will realize that this is 1. So which means we can ignore it. Remember, this would be 0 by 0 form. Okay. Now comes this part. Now in this case, what do we do? Apply L'Hopital's rule again here, and tan x is sec square x minus 1 by 3x square. So here I am applying L'Hopital's rule. Now again denominator is still 0. So let's differentiate it once more. So limit as x approaches. So again I'm applying L'Hopital's rule. Sec square x minus 1 will become 0. So sec square x differentiation is what? 2 sec square x tan x. See, these are some of the standard ones that if you remember, these things will become faster. Otherwise, you'll have to start now, differentiating roundabout way. And this will become 6x. Now here we have tan x by x. Yes, tan x, x. So let's split it. Limit as x approaches 0 of 2 sec square x by 6 times limit as x approaches 0 of tan x by x. This is again 1. Okay, so this becomes 1. So we can ignore it. 2 times 3. Now can we take the limit? Again, if you remember that sec x or sec 0 is what? Fine. Otherwise, 1 by cos square x times 3. And we know cos 0 is 1. So 1 times 3 is 3. So the limit is 1 by 3. Okay, finally, limit as x approaches 0 of cos x to the power of 1 by x square. Let's say y is this limit. X approaches 0 of cos x to the power of 1 by x square. Now we want to bring down the exponent. So log y is equal to limit as x approaches 0 of 1 by x square log cos x. Okay. Now what do we do? Limit as x approaches 0 of, let's differentiate. L'Hopital's rule. 1 by log cos x difference derivative is 1 by cos x times cos x is minus sin x, and denominator will become 2x. Okay, so limit as x approaches 0 of minus sin x, this cos x can go down, so we can say 2 cos x, which is, remember, sin x by cos x is tan x, right? So this can be written as x approaches 0 of minus tan x by 2. It doesn't help us because we don't have an x. Do we have? Yes, we have 2x, this 2x, right? So once we take the limit, minus tan x by x becomes 1, and we are left with 1 by minus 1 by 2. And don't forget, this is log y is equal to minus 1 by 2. We want to get rid of log, so e to the power of. So this also becomes e to the power of. So this and this gets cancelled, and we are left with y is equal to e to the power of minus 1 by 2. And that's the limit. So since we are talking of finding limit, ideally we should say L is equal to, right? Because that is what stands for limit. So what happens is it becomes much more natural to say that limit is equal to e to the power of minus 1 by 2. So that is indeterminate forms. Bye for now.